Oh, looks like you're ready. Click here. So there's an extra button you have to click. All right. So there's an extra button you have to click. Let's see. All right. So there's an extra button. Let's see. All right. Looks like we're there. At least. So. Okay, this is going to be weird. All right, finally. Okay, I think we did those. So let's go to the other one, which would be 4. Okay, so the question is, I got to be able to figure out. Let's see. Let's look at the. It looks like. It looks like I can get from here down to almost the bottom. So. Okay, so the question is, how does it look on the stream? Okay. Okay, so to me, oh shoot, I can go all the way down to maybe there. So I guess that's probably the best I'm going to be able to do. Okay, so this will be recorded. So there we go. This is the silliest thing I think I've ever done, but hey, that's okay. So you got um, equations of motions for constant acceleration, where g goes down, and it's a value of 32.2 feet per second. And so the motion follows the x naught, t, and there is no acceleration. No acceleration in x, but there is acceleration in y minus g t squared over 2. Acceleration in y is minus g. So the question is, how do you solve this? You got golf ball that starts at 80 feet per second. So what I'm going to do, pick my coordinate that goes like that for x, this for y, and then if I have that, I need to break the initial velocities into v x naught, v y naught, but the thing is 80, so this is 45 and that's 45. I'm going to take a second and see how this looks on the stream. Let's see. Okay, let's see. It looks okay. I'm going to take a second and see how this looks on the screen. Let's see. So, looks like I might be able to go down to right there. Okay, so if that's the case, then what you have, Vx naught is equal to 80 cosine of 45, or 80 over square root of 2, but Vy naught's the same thing. Oh, I can go further than that, so I can get the whole board. Somebody figured this out ahead of us. Now, since I picked the initial location, x naught equals to y naught equals to 0, since I picked that, these two terms go away. So now what I get is x is equal to 80 over square root of 2 t, and that's pretty much it. And then I get y is equal to 80 over square root of 2t, but I get minus 32.2 over 2 t squared. So this is convenient because I can say t is equal to square root of 2 over 80 x and then conveniently put that t back in there, and unfortunately put it back in here as well. So I end up with y. If I put this, okay, maybe the best way to do it is to put it in right here. So I'll put it in here. X. Then I'll put it in right here. Then I'll square it. Now I have that 2 square root of 2 cancels that one, add 80 cancels that one. I have an x left, that's kind of convenient. That's like slope of that line, although it looks like it's not 45 degrees. It is 45 degrees. Oh, mistake. I have made a mistake. Okay. My mistake is this. It's 10 degrees plus the 45. So let me fix that. So let me move over. 10 and 45. 55. So unfortunately that makes this problem a little harder. And I think I can flip back and forth between the two screens on the stream, I think. And we'll do this in a combination of MATLAB, which, if that's the case, let me take a second and get MATLAB to come up. It'll take a minute. So this means Vx naught is still 80, but this time it's cosine 55, and this is 80 sine of 55. Let me get MATLAB out of the way. Nobody ever said I wouldn't make a mistake, so 55, cosine 55, sine of 55 going up. This doesn't look like 55. It should be kicked up a little bit more. Then I've got a problem here. So let me move this over. This becomes 80 cosine 55, and this becomes, I'm going to back these two up a little bit. Here, let's fix this. I'll move the square over. Move this over. Okay, so now I have 80 sine of 55. And I have t. You know what? I'm going to carry it this way. One more step. And now I'm going to come under this and say t is equal to this 80 cosine of 55. And now I'll stick this in here and stick this in there. Once I do that, I get y is equal to 80 sine of 55 t. And I'll move the t over because in the side of the t, I'm going to have an x, but this part is going to go under here. And now I'm sticking this t over in here. And got an x here. And then I got, that'll be squared. But also, I'll tell you what, let's do it this way. X over 80 cosine 55 squared. That's the t. And unfortunately for myself, that's the t as well. X over that. So the 80 cancels. And if it was 45, I'd have sine of 45 over cosine of 45, be the same thing. So in essence, this is going to be the slope of that line at the origin. So the other way you could write it, tangent of 55, x minus 32.2 over 2 x squared over 80 squared cosine squared of 55. So what you have here is no longer a parametric equation. What you have is an equation that says y is equal to function of x, or more commonly written that way. So now what you're trying to do, try to write the equation of this line. Y is equal to ax plus b. Well, the intercept is right there, so the b is gone. And then all you have is the slope. The slope is the rise over the run. Or the tangent of 10 degrees times x. So all you have to do now is set these equal. In other words, let me check the stream and see if you can see this equation. Let's see. Bring it up on my phone. Where'd it go? There it is. Okay, go all the way to the end. Yeah, so apparently you can see this. And apparently you can see all the way to the top of this. So what I can do now, I can do this and set this equal to, so this is the parabola that's upside down that kind of goes like this. This is y is a function of x. And this is another y, a function of x. And so what you do is you set these two equal. So and when you set them equal, you'll have a quadratic term, a linear term, then another linear term. What's convenient is you know one of the solutions is going to be an intercept occurs right here. So x equals 0, y equals 0 gives you one intercept, which means you can simply divide out the x's. And if you rewrote this equation, taking out one of the x's, because you can do that, you would have tangent of 55 minus 32.2 over 2 x 80 squared cosine squared of 55 equals to tangent of 10. So I divided out one of the x's. So in other words, I came in, divide the whole equation by x. And I can do that, take out the x. There is no constant term. There's this term, which is x, x squared, and then x. Now I can solve for x. And that'll give me, I guess I could move this to that side and this one to this side. And I'd have tangent of 55 minus tangent of 10 over that, which will be 32.2 to 80 squared cosine squared 55. And that'll give you, should give you this point right here. Now, they'll give you the x. They won't give you the distance. So in other words, looks like that. You just got the X. With that, you can also get the Y, or you can just say, hey, I want to know the distance. This is the X, this is the Y. What is the distance? And you could use the 10 degrees, and in this case, you'd use the cosine. In other words, cosine of 10 degrees is equal to X over the distance. And that would be one way of finding that distance without as much trouble. Okay, I'm going to check the live stream. It looks like it's working okay. It looks like, I'm just trying to see. Oh, I can go past here. So here's the edge of the board. But it doesn't look like it can. Of course, I can move the camera, but I think that's okay. Yeah, so you can see this edge, but you can't see the far edge. But it doesn't look like it can. Of course, I can move the camera, but I think that's okay. It seems like it's working okay. It looks like. Well, let's see how many people are participating, and I may call it good with one problem. Let's see. If I go to Google, where if I go to the content, no, I go to here. We had 3 people for a while, and then that last person was me on the phone. Okay, so I'm gonna shut down for now. We'll pick it up next time. This is good. It's okay. We did a first run at it, so I know it's doable. So we will end the stream. But before we do, I want to see if I can, in the middle of it, do something like so. And I do that, and does that come out on the stream? So it looks like, yeah, it does. Okay, so I can move back and forth between these. That's bizarre. Well, it's nothing like being a guinea pig, so it works. Okay, so I guess I'm done.